Hello, and welcome to my video on the January 2019 Algebra 2 Regions, question number 20. In this problem, we see that we have sodium iodide 131 is used to treat certain medical conditions and has a half-life of 1.8 hours. The data table below shows the amount of sodium iodide 131, rounded to the nearest thousands, as the dose fades over time. So in the table, in the first row, we have the number of half-lives listed out, starting at 1 and going up to 5 half-lives. In the second row, we see the amount of the sodium iodide that corresponds with each of our half-lives. So we are then asked to find what approximate amount of sodium iodide 131 will remain in the body after 18 hours. So to do this, I think the easiest way to do this is to use the data in the table to help continue to calculate the amount left after a certain half-life until we get to the corresponding number of half-lives that are within 18 hours. And since the length of the half-life of sodium iodide is 1.8 hours, to calculate the number of half-lives within 18 hours, we can take 18 and divide it by the length of the half-life of 1.8, and we would get 10. And that's the number of half-lives that we would have to calculate in order to answer this particular problem. So using the data in the table, again, we know what the amount of sodium is after the fifth half-life, and we can just continue to calculate how much is left after each subsequent half-life after 5 until we get to the 10th half-life. So for example, after the 6th half-life, the amount of sodium left, what we can do is we can take the prior amount left after the 5th half-life and just multiply that by 1/2 or divide this by 2. And that would give us an amount of 4.344. That would be the amount of sodium left over after the 6th half-life. And as I mentioned, we can continue to do this, calculate how much is left after the 7th half-life, and then the 8th half-life, and then the 9th, and so on until we get to the 10th half-life. And when we get to the 10th, we would be left with 0.271 of sodium iodide left after the 10th half-life, and that would be our answer. And this definitely would be perhaps the easiest way to answer this problem. But another way you could answer this question to utilize material that we learned during the year is to perform an exponential regression on the data on this particular table to get an equation and then use that to find how much is left after the 10th half-life. Now, the reason why we can perform an exponential regression is that a half-life means that there's a decrease in the amount of our substance by 50%. And anytime you have a percent decrease, that means we're dealing with an exponential function. And therefore, we could do an exponential regression to get an equation to model this data. So if I go to my calculator, to perform the exponential regression, first remember that we have to input the data, and we would input the data by hitting Stat and then Edit. And here's where we input our data. Now, if you already have data in your calculator that you don't want, the quickest and easiest way to get rid of that data is to, within that column, go up to the top of the column and then just hit Clear, Enter, and this will clear out the data in your table that you don't want. And then after the data is cleared, you can input your data for your specific problem. So then once you have your data input into your calculator, remember what columns you input that data into. Here, my data is in columns L1 and L2. And then we go back and hit Stat, and then Calc, and then if we arrow all the way down, exponential regression is option 0 here. And here is where we would select that to help perform the exponential regression to find our equation. And as I mentioned, it's good to know where your data is located. My data was in L1 and L2, those columns. If your data is in a different column, note that above the numbers here, 1, 2, 3, 4, 5, 6, in blue, we see the notation for the different columns that your data could be in that you could change if your data is in a different column. But since my data is in columns L1 and L2, I'll now just go down to calculate, and here's my equation. This is the exponential regression equation. And so now we could use this data, this equation, to actually find out how much the data is left after the 10th half-life. So we would plug 10 in for x using this equation. And once again, if we do that, we should get a value of 0.271. So if I take my equation, 2y equals 277, 9936 times essentially 0.5 to the 10th, we'll get that value, 0.271. So I hope this video helped you out with this particular problem. As always, good luck with all your studies, and thank you for watching. Take care.